Is the audio on? Whoa. It's so weird being in a stage that's actually built for this, where you don't hear yourself when you talk. That's quite neat. And it's weird being in here. I'm here once a year for the MVP Summit, but I'm sort of on the other side of the podium. So welcome, everyone. Having a good day? Yes. Oh, there's a Swede in the crowd. Awesome. We're going to do the presentation in Swedish. Is that okay? That's the way it works in Sweden. You have one English-speaking person in the audience, and I have to do it in English. There's one Swedish-speaking audience here, so I get to do it in Swedish, right? That's how it works. That's how it works, yeah, I believe so. So I'm going to be talking about the solid principles in .NET and C#. And my name is Chris Klug. I work at a company called 1337 in Sweden. And my official title is Ninja. I love it. It's my new job. I start working on Monday. And all their consultants are called ninjas. We're apparently supposed to be good at what we do. But I do have a kind of a weird background, because I've been working with software development since sort of 2000 professionally. So I've been doing it for way too many years now. But I do spend quite a lot of time traveling around, talking at conferences, doing user group things. I have some Pluralsight course stuff and a bunch of other stuff as well. So I like giving away some of the hard-earned knowledge that I might have picked up along the way. And as I said, today's topic is solid principles. But before we get started, we're going to do some geek workouts, right? You all know what that means. That means arms up. So we're going to, and you're allowed to switch arms along the way. That's fine. If you can't hold your arm up for more than 30 seconds, you're allowed to switch and use the other arm. We are developers, so we don't have the muscle strength of a normal person. So, solid principles. How many of you have heard of the solid principles? Arms up. And this is where it gets complicated with my session, because keep them up. You're allowed to switch, as I said. That's OK. You can go back and forth. So it's pretty much everyone. If I change the question to, how many of you can name all the 5 principles? OK. Still a few. Still a few. And how many of you can come up here and explain Liskov substitution principle? This is fantastic. It's the same thing wherever I go in the world. I've been doing this presentation since 2014. Many, many years now, at many different conferences. And it's quite cool to see my very unscientific sort of check of people in the room. 90+% of the room will always have heard of the solid principles. When you go and name them, it drops down, and you're left with, say, 60%. And when you ask, explain Liskov substitution principle, this room was actually better than normal. There is normally one hand. Doesn't matter the size of the audience, there's one hand. And then you say, well, come up and do the presentation, that hand goes away. So it's pretty much a standard crowd. Apparently there's 2 more intelligent people in the room, or people that have read this than there normally. But we're going to go through it, and you're going to get a full read-through of what it means. And to be perfectly honest, even if you don't know the solid principles, if you've been doing software development for a few years, you have come to these conclusions yourself. I'm pretty sure. It's just that they've put names of stuff that we learn over time, and said, here are some names and some standards and some principles we can use, so you'll feel quite comfortable. So when I demo this, I do a lot of talking and do a lot of slides. But I do have an application. And I try to demo the different stages of solid in an application. So I've built this application. And it's an awesome application. If you've never been on stage and talked about something for an hour, you have no idea how hard it is to build an application that is big enough to cover what you want to show, but small enough to be fit into 1 hour. So that's why I have a stupid application. I'm very well aware of it, but it will just have to do. So I sat down and I wrote this application, and it is a brilliant application. It has 2 classes. It's got a document, which is fairly simple. If that is a problematic class for you to get your head around, wrong crowd, wrong conference, wrong line of work. So I have a program. It's not much more complicated, but it's a little bit more complicated. Let's remove that and that, give us more space. So it's a simple console application, because we all build console applications, right? No, we don't. But console applications do what they should do and keeps everything else simple. So I've got a source file and a target file. So this is a format converter. My boss came to me, my fictional boss came to me and said, we need to convert a bunch of files from one format to another format. So we're going to get a source file and a target file name. I'm going to use file open read to read the source file, create a stream reader, read all the input here. Then I'm going to parse that to an X document. And then I'm going to take that parsed X document and convert it into a new document. And then I'm going to take JSON.NET and JSON convert and serialize it into a string. And then I'm going to write that JSON to the target file name instead. So basically, it takes XML and creates JSON. Fairly simple. Would I go ahead and change this in a real-world application and make it solid and add 52 different classes instead? No. Because this is too simple, but for what I can show you, this will just have to do. So I wrote this, and then I said, this works, that's fine. And then I went through it once and made it a little bit better. So I created this version here, where you can see the outline of what's being done. So basically, I just broke it into method calls. So we got get input, get document, serialize document, and persist document. So it's just split out into functions, which in this case would probably be fine. But I'm not happy with fine. We're going to take this and make it solid and make it composable and changeable and be able to do a bunch of other things that our fictional boss didn't actually ask us to do. So that's the application that we're going to see along the way. So for those of you who didn't know what the names were of the principles, they are this. It's the single responsibility principle. I'm sorry if it does some weird line breaks, like single responsibility. I had to change the presentation slide deck for this conference. So we have single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle, not dependency injection principle. Two different things. And we're going to take one at a time. What I kind of like about Solid is that, to me, I start from the left and go to the right. So I start out by looking at my application, saying it needs to be single responsible classes, and then I do that principle. And then that leads on to, once we've started doing things single responsible, we want to go and make them follow the open close principle. And then when we have that, we probably want to have a look at Liskovs, and then we probably want to end up with I and D. So we can go one step at a time, and then we decide how far we want to go, kind of. So we're going to start out with the single responsibility principle. And that is probably the one that we all learn, right? One class should do one thing. We should not have God classes and all of that. So I Googled it, and the definition is, a class should have only one reason to change. I think that definition of that principle is crap, because it's very, very broad. It could mean a whole bunch of things. Whereas if we want to go and be more specific about how I see it, is basically there can only be one requirement when changed that will cause a class to change. So basically, if you look at your requirements document, if there's any two requirements that can affect your class and cause you to go back and change a class, you're doing it wrong. But if you have classes that can only be affected by one requirement, you're single responsible. Make sense? Complete silence. Yes. Thank you. I'm going to slowly convert you in to go, yes, Chris. Okay? So, look at this. I'm feeling so happy. How many of you, this is just a side note on my own, it's just for fun, because I've asked this once again at every time I do a presentation, but how many have grown up doing software development according to the idea that nouns are classes, verbs are functions, and adjectives are their properties? There's half a hand coming up, a full hand, a couple of hands. Yeah, if you have that idea when you build your application, you can pretty much throw it out the window, because it doesn't work anymore. If you want to be solid, we can't think of the world like that anymore, because we're not going to be able to do the solid principles. In a lot of cases, functionality also becomes classes. So That idea is cool when you're doing domain-driven design, and you should probably keep going if you're doing domain-driven design. But to me, domain-driven design and solid principles are a little bit at ends of each other. It's like we cannot really do them both. So for this talk, ignore that idea completely. For the real world, it's up to you. So what I did in this case is that I looked at what I was doing. And I just had a bunch of functions. But even if I just had a bunch of functions, I could still break it in and make those functions into classes. So I created a single responsible version of this. And by the way, if anybody wonders, the code that I've got here is available somewhere. I'll check that. I think it's on a GitHub repo. I'll get that sorted for you afterwards. So if you want to see the code, it is available. But what I did is I took my program class here, and I broke it apart. So I now have a format converter. This is nice because it makes my console app, my main program class, fairly single responsible. The only thing that can affect this class is if I need to host it in another way than the console app. Then I need to go in and change this class. There's nothing else that will ever change inside of this, so it has one responsibility. And then if we look at the format converter, go over there. The format converter has split out into a bunch of different classes. So it has a document storage class, an input parser class, a document serializer class that are all set up in the constructor. And it has a convert format that takes a source file name and a target file name, and then basically just delegates all of the functionality to the other classes. So it tells the document storage that I want to get the data from storage. It tells the input parser that I want to parse the input. It tells the document serializer that I want to serialize the document that I got back. And it tells the document storage to persist it. So this class, my format converter, has only one responsibility, and that's keeping the flow of the application. What order should things be called? And the only thing that can change in here that causes this class to change is if the flow of my application changes. Chris, you suck. Yes, I do. I am so lying to you right now. I will fix this along the way. Because obviously there is a problem in here. Because it's also responsible for instantiating all of the classes, which means that not only is this class responsible for the flow of my application, it's also responsible for what other classes are doing their thing. I will sort that out as we go along. But ignore the constructor for now, and other than that, what it's doing is just the flow. Make sense? You are more than welcome to call me out and put up your hand and tell me I'm wrong. That's fine. I will then turn around and tell you that you are wrong, and we'll just go from there, if that's OK. So what are these classes doing? Well, if we look at the document storage one, it's pretty obvious what it should be doing. We'll look at the document storage. All I've done is I've cut out the different file access parts. So basically the get file data from file and the persist it to disk is in here. If we look at the input parser, it is the only thing it does. It takes the string, converts it to an X document, and then converts it to a document class or document instance. And the serialized one is my favorite. Document serializer, there it is. Because it's a one-liner. I have literally taken JSON convert.serializeObject and put it inside a class of its own. I could have gone ahead and said inside of my format converter that instead of calling document serializer.serialize, I could have taken that one-liner and put it in here and had JSON convert.serialize in here. But I don't want to do that because all of a sudden I'm locking everything down, which I will fix later on, in saying that this class would then not be single responsible anymore because it's doing the flow of the application, but it would also all of a sudden be doing the serialization of the object or the document. So all of a sudden I wouldn't be able to switch out and go from JSON to some other language or other formats. I would be stuck, and I would have to change this, and I would have two reasons for changing this, not the flow as well as the format that I'm converting to. So we do end up with these small classes with potentially even just one-liner classes, class, one function, one line inside that function, and that's fine. However, I did go through, well, I shouldn't admit this, but I actually Googled something regarding this presentation today and ended up on Stack Overflow that link to a video of me talking about this presentation. And it happens very often that I Google and I find my own blog. That's just weird, but you forget things. I forget things. It was interesting because somebody in the comments said that single responsibility should then mean that a class should only have one function, because that's the only way that it's single responsible. And that's not true. A class can have a bunch of different functions and still be responsible for one thing. It can have a read and write class that reads and writes to disk is still single responsible as long as the requirement is that it will always read and write to the same kind of repository. If you then say, I want to be able to read from one thing and write to something else, then all of a sudden it's not single responsible because we have two requirements. So don't think that single responsible means one class, one function. You're going to end up with a lot of classes in that case, and it's going to be complicated. So edge cases for this is kind of interesting, because I don't know why, and I say this every time I do the presentation. I don't know why I came up with repositories as a thing, but I think I was working on a project when I wrote this that was interesting. Repositories are generally single responsible. They're responsible for getting things from a database and putting things into a database, right? Whether it's a SQL database or NoSQL, or it reads or writes to disk or whatever, they are single responsible because the only thing they do is they take an object and they persist it and they get it from persistence and give it back to you. That is only true when your repository reads and writes from the same store. If you're doing sort of CQRS-like kind of things where you have a commanding pattern on one side and a read thing on the other, so you have write models and read models, all of a sudden your repositories aren't actually single responsible. Then you need a write repository and a read repository because they're writing and reading from two different sources that can both be affecting your repository. So it's interesting how something as simple as single responsibility is not something that you can take for granted from project to project, saying that in my last project I built something that was very, very similar and that was single responsible. Because single responsibility always has to do with the requirements that you have in your current project. Not what you had in your previous project or what Joe had in his other project. It's about your current project in all situations. And what are the benefits of this? Well, first of all, you end up with very small classes. Why are small classes good? Because when you make small things, it's hard to mess up big. No, it's true. I challenge you. I will challenge everyone in this room to mess that class up. Having that said, later on in this presentation, I will explain to you that I messed this class up and actually had to change it, because I have made a mistake in here. But that's a personal mistake. It could work still. But the thing is, the smaller the classes, the less code we put in there. The less code we put in there, the less likely we are to screw up. Right? Yes. In generally, the more we do, the more likely we are to mess up. And the more we can break things into smaller things, the less likely we are to make a mistake, hopefully. We do end up with a lot of classes, but each little class has one thing to do, and it's fairly easy to get that thing right in most cases. And also, when something goes wrong, it is way easier to go back and say, this thing I'm doing over here is breaking because it's not writing to the disk properly. Sweet, it can't write to disk. I know exactly what class that is, because that class that is responsible for reading and writing to my disk is this thing here. It's not, oh yeah, so writing and reading to disk, that's being done in 57 different classes depending on what thing you are doing that needs to write to your disk at that point. So keeping them small and simple makes everything easier. It's not like, I wasn't on the project, and I'm not going to say, I don't even know what client it was, but basically I have been employed by a company where we had a client that had a 700-line long constructor. That is impressive, in a bad way. Keep everything small. Small things are good, says the guy almost 2 meters long on stage, but small things are awesome, right? So we want to keep it small. Next one, open-close principle. The worst one to explain. unfortunately. I take Liskov over this every single day. So the definition is software entities should be open for extension but closed for modification. Does that make sense? We should write classes that we can extend and modify and make better without touching the classes. Simple, right? I've refined that to my own definition, which is once a class is done, it's done. Basically, you write your class based on the spec, based on what you need at the moment. So here are my requirements. This is the class I need to write. This is the way it should work. And once you've implemented your class based on those requirements, you don't touch it again. It's done. If your requirements change, you don't go back and change that class. You either inherit that class and override the required methods and make your changes in a new class, or you create a completely new instance of it and hide it behind an interface. But basically, you don't modify things, you always create new stuff. Does that sound smart? It is awesome. So how many of you are doing TDD? I won't yell at you for doing it. There are a few of you. The best thing about this is if you're doing TDD and you end up with having a lot of tests, running all of your tests takes time, right? And what you want to do is you want to make sure that your test runs as fast as freaking possible because it needs to run all the time. With this principle, once you have run all of your tests on your class, you can turn them off because you don't need them again. There's no reason for you ever to run tests on a class that you don't change. So whenever your class is considered done, you can disable all of those tests because you don't need them because you know it works. Does that sound good? Yes. Oh, yeah. This thing was something that a guy called Bertrand Meyer came up with a while back, many years ago. And he had one way of defining it, which is that we build everything as we build base classes. So you build a class with all of the functionality you need, and then whenever you need to extend your class or make changes to it because changing requirements, you inherit that class and you make changes to that class in a new instance or in a new class. So you inherit all of the functionality into a new class, and then you can change the API of that class. So you can add new methods and functions and properties and everything, but you leave the existing one and then potentially overriding certain parts to make the base class do what you need it to do. But the idea with his version is that you take the functionality and you inherit that, but you're allowed to change the API by adding new functions and new properties on it. And then somebody came along and said they're going to do polymorphic instead, where the idea is that we use interfaces. And that's the one that I do the most. So polymorphic says that here is an interface. You do an implementation of that interface, and whenever you need to change that implementation, you create a new class that implements that interface, and then you just switch out the old one and shove in the new one. But with polymorphic, we're not saying that you're inheriting the functionality and can change the API. Instead, you're inheriting the API, but not the functionality. So they're actually the inverse of each other, but doing this kind of the same thing. Make sense? Ish. The downside with Meyer and having inheritance chains and class, or rather have classes that you inherit, and you have base classes, and then you inherit something new, and then something new, and then something new, is that you tend to end up with these hierarchies of objects, these chains of objects that you have inherited over time, and they become brittle. And all of a sudden you realize that you've made a change, it causes problems, you need to shove something in further up because it needs to be implemented in these different things, and it is complicated, whereas polymorphic says, here's the API, here's the interface that you need, and then you can go and do whatever you want. So I personally prefer polymorphic, and that's what you're seeing most of. Most of us are talking about you put an interface in and then you implement that interface. Very few people today are saying, oh, you get this base class, and then you write that base class in the right way and make just the right methods virtual so you can override them and all of that. Base classes are hard. They're really hard. What you do is what Microsoft does in a lot of cases. They make the class sealed so no one can inherit it. That's awesome. You don't have to care about anybody messing up your class in the future. On the other hand, you then end up with, oh, I need to change this thing, and I can't. Whichever you use, just make sure that once your class is done, you stop messing with it and you create a new one. So if we look at what I've done here, I've created a new thing in here. We look at the OCP one. Go in here and we look at my program. You'll see that my program is pretty much the same. Nothing has changed in here. But if I go in and have a look at my format converter, you'll see that I now have an iDocument serializer, which is an interface, so basically polymorphic. And I have an input parser, which is a base class. So you see here that my input parser happens to be a JSON input parser. And if we have a look at these two things, we can look at the iDocument serializer to begin with. So I created my interface and said, here is my interface, it needs a serialize method. And then I implement two different versions here, and I said that it was hard to mess up this one-liner here. I am not kidding you, I did mess it up. So I did write this, and then I started serializing things just to see that it worked, and I realized that all of my properties were serialized in Pascal casing, not camel casing, as JSON should be. But it was interesting because it gave me this opportunity of highlighting the fact that a tiny little thing, like telling this JSON convert method to do camel case instead of Pascal casing, I don't go into this class and change this class. I just don't. This class is done. I have not had a changing requirement as such. Or rather, sorry, I've had a changing requirement. It wasn't a bug, but I have a change in requirements. Changing requirements means I get a new class. So I go in and I create a camel case JSON serializer instead, and I make my little change in here. So instead of going in and modifying the class I already had by just adding my JSON serializer settings, I create a new instance. Yes?
Why would you not consider that a bug?
It kind of depends on how your requirements are written. My requirement, I wrote the requirements, which basically meant that there were no requirements.
You messed it up, so in that case...
Yeah. Now, the requirement initially was it needs to serialize as JSON. And then down the line, seeing the result, I came up with another requirement that said it needs to be camel case as well. And it's not a bug because the original requirement didn't say that it should be camel case. It said it should be JSON, still JSON. So it's a new requirement. It's a bit of a up to you, to be perfectly honest. But it highlights the fact that, to me, especially for this demo, you just create a new instance of it and fix it. So you're allowed to go back and fix bugs. A bug in something is definitely something you go in and change the class and you fix the bug. But a change in requirement is a new implementation. So I have my polymorphic in here, where I do get the serialize method defined, and whenever I use it, I know what the API is like, but I don't know what the functionality is. So if we look in here, I do know that my iDocument serializer has a serialize method, but I have no idea what the implementation is as such, because this thing here, that is really hard for you guys to see, but it does say iDocument serializer. So I just have the interface for it. And the other one I have is the JSON input parser. So JSON input parser, if we look here, it's just an input parser. So this idea builds on the Meyer instead, where we have a base class. And if we go and look at the input parser, I have a class here. Let's do that. You can see I have my input parser. And what it does is that it takes a string and it converts it from an X document into X document and returns it. But just to show that I can then inherit that, that's a virtual method, I created a JSON input parser. Because all of a sudden, my fictional boss had a new requirement for me. We're going to be converting not only XML documents, we're going to be converting JSON document as well. So we need to be able to parse both XML and JSON documents. So I just create a new implementation of input parser, inheriting input parser, overriding the method I need, and all of a sudden I can parse JSON documents as well. So now I've also been able to add a bit of functionality. So my application can now parse JSON documents to JSON documents in the same format, which makes it completely useless, but you get the point. we can add new functionality in here. So if I wanted to go JSON to JSON is stupid, but if somebody came and said that I needed to parse some other format, I could just create another implementation, inherit the input parser, override that parse method, and I'm good. But this is a very simple class. In a more complex class, my base class might have a bunch of functionality that I inherit, but I only override a little part of it because I only want to make a little change to it. And the interesting thing about doing it with base classes is how you figure out what you make virtual. That's my next one, potential questions. So if I use base classes, how much of my base class do I make virtual? Do I need to make every single method in my base class virtual so that I can override everything and change all of the functionality? No. Because you also have a responsibility to anybody inheriting your class to say, all methods that I have made virtual and possible for you to override are made in such a way that you cannot screw up. So you need to make sure that any class that needs to be a base class for future implementations needs to be implemented in such a way that if I pick it up and I override one of your method, I can change the intention of what your base class is doing. Does that sound easy? It is pain and hard. I actually believe, this is me just thinking, but I actually believe that that is a reason for Microsoft sealing a lot of its classes. I hate when I look into the .NET framework and I find classes that I want to inherit and override methods on, and they're sealed. But by making them sealed, Microsoft is basically saying, you cannot come and make changes to my class in a way that you can mess stuff up. So by sealing it, they don't have to think about all the potential things I can do to their code and make sure that I can't mess it up, instead of having to make it open and then have to think about all the things that I can come up with to mess up their stuff. And I can think of a lot of things. Trust me. And so can you. And also another question is, if we're doing polymorphic, we're going to come back to that later on, but who defines what those methods are actually supposed to do? If you have a base class and the method is named something and you have an implementation, you have set a sort of a defined what that method is supposed to be doing. If you've got an interface and you only got a name on that interface, it doesn't actually explicitly tell you as a developer that this method should be doing X, Y, and Z. Hopefully it's named properly, so you don't get one of those interface A with function B, because that's going to be really hard to implement. So they both have good things and bad things. And what are the benefits of this? You don't mess up. We come back to that. I'm not kidding. I do come back to the fact that you won't screw up as much. That's kind of the whole idea with the solid principles, is trying to get us as developers to not screw up as much as we normally do. Step 1, make it single responsible. You can't mess up small classes. Step 2, don't modify classes. If you know that a class works, as long as you don't touch it, it will always keep working. If you introduce a new class with new functionality, then you might introduce new bugs, absolutely. But if you're introducing a whole bunch of new features in new classes and somebody comes up and says there's a big bug here, you can always go back and say, I'll just use the old class until my new class is properly implemented or works. So we have this fallback idea. We don't end up messing up existing things that already work. So we know that if a class has worked at one point, it will always work because Joe hasn't been in there modifying it and broken it in the last check-in. So there are some good ideas behind it. The next one, I'm going fast. This is going to be good. Next one, Liskov's substitution principle. And that was the one that there were 3 people in the room that could explain. Anybody want to come up and do it? There's one guy. I'm so close to telling you to do it. I won't. Liskov's is cool. And it's actually not that hard. It's just that it sounds very hard. Because the definition is, let Q of X be a property provable about objects X of type T, then Qy should be provable for objects Y of type S, where S is a subtype of T. Yes. Absolutely. And I am 100% sure that this is true because Barbara Liskov, who is probably way smarter than I am, has said it. What does it mean? Don't know. Not really. I looked at this and I'm like, not working. I can't do it. So I read and I looked at it, and all of a sudden what she said made sense. But it's easier to give you my explanation than trying to explain that to you. So my definition is a subclass should behave in such a way that it will not cause problems when used instead of the superclass. That is pretty much what she's saying. So what she's saying is that if you're trying to call a function on a class and you exchange that function for a subclass of that class and call that function, there shouldn't be a problem. That is pretty much what she's saying. Which kind of makes sense, because we are trying to do all of our classes very small, single responsible, and then we made them open close, so we're supposed to create new classes all the time. New classes all the time also means that we're going to create a lot of inheritance. We're either going to do it polymorphically and create other implementations under an interface, or we're going to inherit classes and create new instances. Either way, we're going to be shoving in different classes to different parts of the system based on the idea that they have the same interface or the same base class. So we need to make sure that our classes that we build don't all of a sudden cause problems in our running application. That is kind of what we're trying to do with Liskovs. So to do that, Liskov came up with a couple of rules. And they're actually quite easy to follow-ish. Contravariance of methods arguments in a subclass is OK, and covariance of return types in the subclass is OK. Does that make sense to everyone? Anybody want to be honest and put up your hand and say, no, I have no clue what that means? So the thing I Googled before was covariance and contravariance. This basically means that if you're inheriting a class, when you have a function in your class, your subclass is allowed to make the input parameters less specific. So if my method takes in a sports car in the base class, my subclass is allowed to take in car, which is much more generic. So anybody who's used to passing in sports cars into the function, it won't break because all of a sudden I am expecting just cars. OK? And for return types, it's the other way around. My subclass is always allowed to return more precise things. So if my function returns car, my subclass can return sports car, because anybody using that class is expecting a car to come back. It doesn't really matter if it's a sports car or an SUV. It's a car, right? So it's fine with that. My favorite thing about this rule is that we can just ignore it. I'm just bringing it up because it is one of those rules you'll find online. To be perfectly honest, you can't ignore it. Are you all doing C# or VB.NET? How many of you are doing JavaScript? You guys are screwed. You need to look at this. Those of you who are doing C# or VB, you can just ignore it. It is impossible to break this in C# and VB. Because whenever you inherit a class in C# or VB, you cannot change the signature of the method. Ergo, you can screw up. Somebody on that, I'm now telling you way too much, that I actually read all of the comments from my video on YouTube as well. I want to see what people thought about my video. I have too big an ego. Somebody was saying that I was wrong. Because I'm lying at point sort of 27 minutes in, I'm lying. Because it is absolutely possible to break this. Because if you use the new keyword in C#, you can change the signature of a method. Yes. But that guy didn't think about the next step. And the next step is that I'm going to be passing in my subclass instead of my superclass, right? So the method that is using my class is going to handle it as my superclass, right? Does anybody know how the new keyword works? The new keyword means that that method will only be called if the class calling it has a reference to that instance in the form of that specific class. If it has a reference to that instance, but as the superclass, it will call the superclass's implementation instead, so you cannot break it. I am lying though, because somebody emailed me at one point and said that there is a way to do it if you do some form of generic arrays. You can apparently get the array generic thingy to break it somehow. I just looked at the code and said, that's really awesome. I'm not covering that. If you find out how to do it, you're more than welcome to email me.
If your subclass throws exceptions on inputs the superclass would accept, that would be violating the Liskov substitution principle.
I'm coming to it.
All right.
I've got you covered. We'll sort that out. And actually, I'm going to give you an example that I normally don't give because I hate the example, but I'll show you that. But we'll come to that. So the next rule is, ta-da, the segue is awesome. So what he said is that you're not allowed to throw exceptions. This is a little bit of a difference. So he said that your subclass is not allowed to throw exceptions based on the inputs if your base class or your superclass isn't throwing with those inputs. That is true. And there's also another, this is slightly different, but it's kind of the same. I will come back to your exceptions. It's actually the next one. But it says you're not allowed to throw new exceptions unless they are subclasses of previously thrown ones. If you are, I am continuously talking about when you're inheriting, but it's actually exactly the same if you're creating a new instance of something that implements an interface. So I'm just talking inheritance because it's easy, but interface is the same idea. But the idea is that when you create a new, inherit something and you override something, you are not allowed to start throwing new exceptions. The reason is that any code that is using the superclass at the moment might have try-catch clauses for all of the exceptions that are being thrown. And then you come, you create a new implementation of it, you shove that into your code instead, and all of a sudden you're throwing exceptions that the existing code doesn't know it's going to throw, which is bad. There are two ways to solve this. No, there's one really, really bad way to solve it, and I normally mention it, and then people probably go and do it, and I feel bad for them. If your base class always throws exception, like the base class of all exceptions in the system, then you can throw whatever you want in your other classes. Don't take this as a suggestion for what you should be doing. You should always throw as precise exceptions as you can, but it can be a good idea to potentially create your own exception types, and then when you have new things, you can inherit from your own exception types and do new things with it. But you cannot throw new exceptions because it won't be handled by existing code. Does that make sense? Yes, Chris. OK, that didn't work. Here is the one that actually segues into or you segue into. Preconditions cannot be strengthened in the subtype, and postconditions cannot be weakened in the subtype. Preconditions in this case, which is what you mentioned, is that we can't all of a sudden have new demands. We can't all of a sudden add new conditions to the system, saying that, oh, all of your inputs have to be X, if that wasn't a requirement in the previous class. So we can't say that we accept you to pass in all types of cars, and then all of a sudden you create a new implementation and you go, if car.make not equals sub, that's really weird, but yeah, obviously Swedish, then throw exception. Because all of a sudden existing code doesn't know that it can't pass in Volvos, because it's been able to do that before. So you can't go ahead and set up new requirements in your subtype. And in the same way, you can't go and change your post conditions and weaken them and say, all of a sudden you're not allowed to do this. Oh, so in the parent class that you used before, it was OK to call this method. But all of a sudden in this new method or new class that I've implemented, you can't call it. That doesn't work. It's fairly easy to build something like that, but it's going to cause problems. So you need to make sure that you're not adding new requirements, and you're making sure that you're not changing what the user of your class is allowed to do. All of these sound very, very simple, and they are in very, very simple classes. But to be perfectly honest, it's very easy to break these things in a slightly more complicated application. And the final rule that Barbara Liskov put up was the history constraint, which is probably the easiest one to keep track of. The history constraint says that if something is mutable and can be changed in the superclass, it has to be mutable in the subclass. So you can't go in and have a mutable thing and then all of a sudden you inherit it and make it immutable. That doesn't work. And the other way around, if you have an immutable superclass, your subclass can't all of a sudden be mutable. So if you have decided that something cannot be changed, you cannot all of a sudden allow something to be changed. And if something has been able to be changed, you can't all of a sudden go and say it's not able to be changed. It kind of ties into this, but it has specifically to do with immutable and mutable. So if we look at this, and I failed. I admit that in every time I do this talk, and every time I have this plan that I'm going to make this better, but I can't figure out how to do it. I couldn't break Liskovs. I'm sorry. I couldn't find ways to break Liskovs in my existing application. I found one place. So in here, in my document storage, that I actually forgot to show you before, it's another one of my abstract-based classes. So document storage is a base class. And on the document storage, I have a getData and persist document. And then I have made one implementation that takes file, that's called file document storage, that reads and writes to disk. I have one called blob document storage that reads and writes from Azure Blob Storage. And then I have one that I called HTTP input retriever, which inherits from document storage, which is cool because it means that I can go and fetch applications, fetch documents on the web. Persisting things to the web is a little bit hard. It's kind of hard to say, I want to persist this file to this URL on the internet and then just hope that you can just go and push it somewhere. It would be awesome to have an open web where everybody was allowed to write to everything, but that's not the way it works. So persist document in this case actually throws a not implemented exception, because this thing doesn't support persisting, it only supports retrieving it. So instead of doing that, I wrote a little demo of breaking the Liskov principles separate, just to show you a couple of samples. And if anybody knows me, you know that it's really weird that I wrote tests, but that's the best way of showing it. So I wrote some tests on an object called car. First rule, covariance and contravariance, I just skipped. I spent about probably 4 hours trying to break that in C# using dynamics and expandable objects and this, that, and everything. It doesn't work. So I gave up. So my first test goes for make sure car can start. My car is very simple. If we look at the car class, I'll show you. I have a car here. Car is very simple. Car is a base class. It has a property that has fuel. It takes a color. It has a method called start engine that unless you, as long as you have fuel, it sets is engine running equals true. If it doesn't have fuel, it throws an out of fuel exception. And it has a stop engine that sets is engine running to false. And it has is engine running and color. That's it. Fairly simple. So my first test is make sure car can start. So I create my car. I call start engine. And I make sure that is engine running is true. Make sense? And then I created broken car. Broken car is awesome. Because if we go and look at broken car, which I can't do through F12 because I have something wrong on my machine. Broken car does exactly what I did before. A broken car can't start the engine. So it throws not implemented exception because it's broken. That won't work. All of a sudden it's going to throw something else and it's going to fail, and all of a sudden we have applications running amok and not working. And the interesting thing here is one of those things that I want to show as well. Shoving your classes through your old tests should work, ish. So if you inherit a class that you have a whole test suite for, taking your new implementation and shoving it through your entire test suite should not fail. It should potentially fail in the way that your return values should be different than you expect and things like that, because the logic inside of it has changed. But all of your tests should still be able to run and should not fail because exceptions are thrown or because you're using the wrong input parameters or anything like that. So that's a pretty good measurement of your classes being okay. Then I went and created Crime Boss car. Crime Boss car is, you know what happens when you're a crime boss, right? Everybody wants to kill you. That's the way it works. So Crime Boss car changes the preconditions. Oh, sorry, postconditions. Because it has a booby trap. So if the car is booby trapped, it sends up it throws a met your maker exception that tells you that you died. So here, all of a sudden, I'm changing it because all of a sudden I'm requiring something new. I have a new precondition. I have a precondition that says my car cannot be booby trapped. My existing system that uses this class has no idea that that's the case. So it cannot take and look at, is this car booby trapped or anything? It's just going to call this method, and this thing breaks in two Liskov principles, or Liskov rules. First of all, it has a strengthened precondition. It all of a sudden expects something new before it can run. And number two, it throws an exception that I'm not expecting. Very, very simple to see in a small class like this, but in a bigger picture with a bigger class and a more complex scenario, it's fairly easy to make these little mistakes. And then I wrote another test, which is pretty much the same. I just found it, I don't know why I wrote two tests, but make sure engine is running after start. So it pretty much does the same thing. It creates a car, it calls start engine, and makes sure that the engine is running. The test is exactly the same. I just have other things breaking it. That works fine. Then I went and built or created a Prius. Does anybody drive a Toyota Prius? I'm sorry. No, there's nothing wrong with a Prius. I'm just going to tell you that it's not a car. It's really not a car. Because if my car definition is that when you turn the key, the engine starts, a Prius is not a car. The engine on a Prius doesn't start until you press the gas pedal. It sets up the electronics in the car and starts it and prepares everything, but ignition isn't actually done until you press well, actually you need to get up beyond a certain speed before the engine starts. Ergo, a Prius is not a car. It's just the way it is. So in this case, it kind of shows us changing, what they call changing invariance. I'm changing things that are supposed to be there. It should be that when I turn the key and something has happened, the engine should be running. Once again, stupid example, but it kind of shows you that it's fairly easy to make a little change that kind of makes sense. In the case of creating a Prius, start engine would basically be, okay, I'll do everything else, but the fact that my engine needs to be started, that is something I'll just ignore in this class because it's not going to happen. And it's something that doesn't potentially seem that dangerous when you do it, and then all of a sudden, your code in production is expecting that thing to be true whenever this method has been called. And then I have stolen car. Here is this million-dollar question. What do you have to do when you steal a car? Nobody's going to admit this. Hotwire it. Yes, when you get into the car, you smash the window, which you do with your elbow, which if you ever try it, know it's going to break your elbow to start with. And then you need to get a screwdriver and break off a piece of plastic underneath the steering column. And then you pull out two random cables. And then you have to touch them first a couple of times, going dish, 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 and it doesn't quite start. And then you hold them together a little, and it starts. That's how you hotwire a car. Probably not a very modern car, but that's how you hotwire a car. Once again, can't do that. Because all of a sudden, in my stolen car, I'm now expecting you to strip your ignition wires before you do something. So Prius, we can ignore because I've already covered that. So in the stolen car, I'm now doing another one of those. I have other preconditions. I'm requiring you to do X before you can do Y, which is not going to work. Very simple little things. Don't add new things you have to do before old stuff works. And my final one is the history constraint. This test makes sure that the car is painted properly. So basically, it makes sure that the color of the car is red, because that's what I've set up here. And then while working on this, I have no idea why, but I found online that you can buy paint that changes color at different temperatures, which is apparently very, very normal in like little kids' toys cars, but somebody painted the whole car in that. So I created one of those. I created a pimped car, and when you change the temperature of it, it changes color. It's a stupid example, I know, but it kind of shows you that changing something from being immutable to being mutable doesn't necessarily mean that you have to make it simple by basically saying, oh, I'm now setting the color to be something else. You can actually affect immutable properties. Like in this case, I set temperature, then changes a property that was immutable before, but by you doing this, you're making that property mutable, which then causes the history constraint to fail. And if you want to know, there's a link here to that car that changes color. At some point, I'm going to get that on my car. It's not going to happen. My wife is going to kill me if I did that. So Liskovs, it's unfortunately a bit hard to show you properly, but the main idea when you start looking at it is don't make changes when you create new instances that will cause existing stuff to fall apart. That is kind of the baseline of what they're trying to do. But what do we do with abstract base classes and interfaces? Because all about Liskovs talks about you are not allowed to do this because the class that was there before you did this other thing. So the class that was already there threw these exceptions, so you're not allowed to throw new exceptions that don't inherit from these exceptions, for example. How do we do that in interfaces? Or how do we do it in abstract base classes? Because in abstract base class, if we say either abstract or pure abstract where we have no implementation at all, we don't know what the precedence is. We don't know what we expect to do. We don't know what exceptions we're allowed to throw, for example. So how do we know that? That's an honest question, because I don't actually know. Yes?
Liscov requires that it be an approvable condition on the base class. As soon as you go to an abstract base class or an interface, it's not an approvable condition on your point of origin, and therefore Liscov does not apply.
Liscov does not apply. That was a good explanation. I've actually wondered this. Liscov does not, OK. So the answer from the gentleman up here is that because it's not provable on a base class that's abstract, we don't have to care. I like that idea. My other solution has always been first come, first serve. So the first guy that gets to implement it gets to set all the rules. That's generally me. I like that idea. Another way, especially for the exceptions that are being thrown, is that in Java, for example, you can on your classes add annotations that says that this method throws these different exceptions, which would be kind of neat to have as well, because for abstract classes or for interfaces, you can actually say that when you implement this, you're allowed to throw these different things. Anybody in here a Java developer? Because last time I mentioned it, somebody came up to me afterwards and said, you should never do that in Java. Sounded like a good idea, sorry. But generally, with abstract stuff and interfaces, it becomes a lot more complicated. So what are the benefits? The benefits to me are quite obvious when it comes to Liskovs. It means that you're not screwing up. That's pretty much it. You don't make changes in classes that you create that then causes existing stuff to break. For some reason, my boss really tends to dislike when I break things, and I'm pretty sure that your boss does it too. So by adhering to this, you're not going to be introducing a bunch of bugs that causes your system to break because you've made some changes in the wrong way. And once again, it kind of builds on SO. So you go single responsible, cool, we have small classes. Open, close, I'm not allowed to change the classes, so I create new instances. When I create a lot of new instances and new implementations, following Liskovs means that shoving my new implementations in won't cause problems because I'm changing the implementations. Next one, interface segregation principle. Probably the easiest one. On the other hand, when you look at the definition, I get a little bit confused. Clients should not be forced to depend upon interfaces they don't use. That makes sense. Have you ever been annoyed when you got too much? Nobody answers. Nobody gets too much in this country, apparently. When I get too much, well, actually, it's true. If you get too much work, that sucks. If you order ice cream and they give you too much, that's fine. I don't really care. Actually, if you break your interfaces down to smaller pieces, they are much easier to implement and they give you more control. But the main thing, I really don't care too much about the control in my case, but the fact that small interfaces with a few functions on it are much, much easier to implement, are more likely to be implemented, and you're going to moan less and say, oh, do I have to implement this interface, blah, blah, blah. I'm going to show you some code. I just want to ask you something. How many of you are ASP.NET developers doing web development? How many of you have been doing ASP.NET MVC development since sort of ASP.NET 2 or whatever it was 3, when they introduced, oh sorry, not MVC, just ASP.NET, when they introduced membership providers? There's one hand, 2 hands. Was that long ago? Ooh, okay, I'm old. So a long time ago, Microsoft introduced something they called the membership provider model for ASP.NET. You would plug in your providers in your web config file, and you could do a bunch of authentication stuff based on that, and you would have a provider that did everything for you, and you could pull in web controls that would then, there was a login control and a login, log out control, and it basically piggybacked on the idea that something was taking care of signing users in and authenticating them using a standard interface. That sucked. If anybody in here works for Microsoft and was involved in building that thing, you should be punished. It's the worst implementation ever, because when you inherited from the membership provider, you needed to implement 27 methods or something like that. Might have been 17, but somewhere in between 15 and 30 methods needed to be implemented. Because they were all in one abstract base class called membership provider. And they had functionality for retrieving users by email, retrieving users by ID, setting up what password requirements you had, making sure that your passwords were changed at a specific frequency, making sure that you were logged out, keeping track of how many times you could do login attempts before you were logged out, how long you were logged out. And this and that and everything. It had this massive amount of things you could implement. But if you ever needed to implement something as simple as, I have a database with users and I want to allow my users to log in, what you would do is you would inherit from the membership provider, you would override those 20-something methods, and you would leave all but 3 throwing not implemented exceptions. Not the way you want to do it. Breaking an interface like that up that has 20-something methods into smaller interfaces that says, if you want to be able to log in, you need to support sign in. That's about it. If you want to support signing out, you need a sign out method. If you want to support retrieving users, you need to support retrieving users by ID and by email. Those things would have been awesome because I could have chosen to implement just the features I needed and not throw not implemented exceptions 27 times. So I introduced some interfaces here. If we go up here to ISP, nope, ISP, that, and we look at my program. Nope, we look at, sorry, format converter is the one, that one. So I have my, well actually I had my interfaces since before, but I've now broken, so to solve the Liskov problem of document storage actually requiring you to both persist and retrieve, I've broken that down to 2 separate interfaces instead. So I have one interface that says I support retrieving, and I have one interface saying I support persisting. So I have an I input retriever and an I document persister. So all the blob storage and disk thing, they implement both interfaces, while the HTTP input retriever that reads stuff off the web only implements one of them. Gives me good control. And then I have some methods down here to get the right implementation. So get retriever for file name basically says, takes a file name, it looks at the file name and says, is this a blob storage URL? Then I want to return a blob document storage. If it starts with HTTP, I want to return an HTTP input retriever. And if it starts with a file document storage, or it doesn't start with any of those, I want to return a file document storage. So based on the file path, I can then figure out what implementation I want back. And all I need to do up here is basically say, get me an input retriever for this file, and I get back an I input retriever. So I get these really small, nice interfaces. And if we want to look at the interfaces, they are, as you can see, really, really small. No, not that one, that one. So I literally only have one method in each. But breaking down those interfaces into smaller ones, it means that I can control reading versus writing, for example, and I can make sure that it's easy to implement the things that I need and not implement a bunch of things that I don't need or don't want to implement. If you want to implement a bunch of different interfaces, you can go ahead and create a super interface by basically saying, this interface implements these other interfaces, and then say, you can implement this one interface. Because you don't want to have classes that says, I implement interface, and then have like 35 different interfaces that you implement. If you have a class that implements 35 different interfaces, you have other issues. Your class is not single responsible in most cases. So it doesn't quite make it, but if you want to have, you can do and say, I want to support both an interface that supports both things and one that supports one or the other thing, for example, in my case. And the benefits are basically, it's much, much easier to implement a small interface. Because you see an interface that has one method, you're just going to go and implement. That's not a problem. If you see an interface that has 27 methods on it, you're more likely to go, no, I'm going to go and change the old code. And also with small interfaces, you can be very precise that when you ask for that interface, you're only allowed to do that one thing that you're requesting. I hate that reason though. I keep hearing that for different reasons, both for this and for dependency inversion, that, oh no, you want to make sure that you don't give them too much. You don't want to give them access to the delete method unless they're actually going to delete something. Okay, so why? Because they might go and delete stuff they shouldn't. Who are they? Because in my world, I work with other developers. I work with other friends, basically, other consultants. I'm pretty sure they are not going to take your code and maliciously go in and use it to delete things. And if they wanted to, they can probably get hold of the stuff that you're trying to get them to not get hold of, because they are working on your code base. And number two, any of you have problem with gnomes at the office? You know, little things that come out at night, power up your computer, knows your password, looks just like you and can log into your machine using Windows Hello, and then can do git pull and change your code and then git commit and git push under your name. Because I think that is the other reason. If you do have that problem, you want to make sure that you don't give people access to the delete thing, because gnomes can go in and delete your database. It's a stupid reason, but it gives you control. And the last one, I got 10 minutes for this one. This is my favorite principle, dependency inversion principle. The idea with the dependency inversion principle is that high-level modules should not depend on low-level modules. Both should depend upon abstractions, and abstractions should not depend upon details. Details should depend upon abstractions. There's a lot of abstraction in there. At some point, we need to implement something. And I don't like that definition. It just... somewhere we need a specific implementation. My definition and the way that I remember it is make sure that your class doesn't depend on specific implementations. Because if you depend on a specific implementation of something, it becomes hard to make changes. Because we're talking about creating new implementations all the time, right? With open-close principle, we're creating new implementations when we need to change our requirements. But that causes problems because if I change a class over here and create a new instance, whenever that is instantiated in another class over here, I need to go and change that class as well. So I need to create a new instance of this because it's newing up the wrong instance. Does that make sense? So the general rule here, I love this rule, and people look at me funny when I say it, and I looked funny at the guy who told me the first time. If you use the keyword new, you're doing it wrong. Is that easy to remember? Does it sound stupid? One guy is shaking his head. I like that. Nobody's going, yes. Has anybody written an application that never uses the keyword new? Half a hand.
Inside of a factory.
Inside of a factory.
Outside of that, yes.
It is. I love that it's a very simple rule. If you're using new, you are locking yourself down. Because you're newing up a specific implementation. You can't new up an abstraction. You new up a specific implementation. If you new something up, you're depending on that implementation, not the abstraction. You're doing it wrong. Here's an example. I've got my application. My application depends on a class called Persister that persists stuff. My Persister class depends on a system IO file class. If somebody comes and tells me that you cannot be talking to system IO file, we're now going to be persisting stuff to cloud storage instead, what do I need to do? I need to go and change the Persister. If I go and change the Persister, I'm going to have to go and change the app as well. And if this was a longer chain with more classes involved, whenever I need to go and make a change, I would go into the place where I need to go make the change, and then I would have to go up the entire chain of classes, the whole object graph, up, and make changes in every single place I do new, because my class down here is forcing this class up here into doing something specific. So we want to inverse that. We want to make sure that instead of this class down here, far down the hierarchy or the object tree, we want to make sure that instead of that telling everybody upwards that you need to use this thing, we want to make sure that that thing says it's the other way around, that I'm telling it you need to use this thing, inversing the dependency. So if I had my app depend on iPersister, Persister depend on iStorage, and storage depend on disk. If a change comes in, I can go in and I can switch out the Persister without touching the app. I can switch out the storage without changing the Persister. So I'm basically making it possible to change things around without forcing changes up the tree, unless you new stuff up. And there are different ways of doing this. If you go to a lot of VS Lives, you might have seen there's a whole talk by Miguel Castro regarding this. He talks a whole session about it. But I have a couple of samples that I want to show. So if we look at the way that I do it, we're going to start looking at manual dependency inversion. And manually doing it is a bit of a pain, because it means that my class out here needs to new up everything. So it news up a camel case JSON serializer, it news up a JSON input parser. Then it tells the format converter that here is the implementation that you want to use. So it passes in the document serializer, and it passes in the input parser. And then inside of my format converter, we're going to have a look at that. It in turn only depends on that interface and that base class. So from here on down in my object graph, there is no dependency at any point of a specific implementation. They all just depend on the abstractions. And then the guy at the top says, I want you to use this serializer and this input parser. Go and do your thing. And it means that I can change out a whole bunch of things without making any changes to the actual classes along the way. I also make one other thing in here. If we go back to my program, I make a call down here to configure storage. So in configure storage, I'm setting up the document persister and input retriever as two factory classes. And what I do inside these is I basically say there are different input retrievers. So I want to register a bunch of different input retrievers. So I say register an input retriever. And if the URL that you're passing in starts with HTTP, then I want you to use my HTTP input retriever. If it is a blob storage URL, I want you to use this thing. And in all other cases, I want you to use this thing. And I do the same thing for the document persister. And these classes here, like the input retriever and document persister, are just factory classes. So they look like this. They have a static read-only dictionary of a func and an input retriever. So you can register your input retrievers and say, here is my evaluator that defines whether or not this is the one that you want to use. And then I have a static method called forFileName that basically just goes through all my dictionary one at a time and says, do you want to be used for this file name? And the first one that says, yes, I do, that is returned. So by doing that in a separate static class, I can then go in here to my format converter, and you can see that I actually get input retriever.forFileName as dependency inversion. this thing only returns the base class, or the IInputRetriever interface rather, the abstraction. It doesn't care what the implementation is. It knows that there is a static class that will give it back an instance of IInputRetriever based on the file name, so I've inversed the responsibility. The downside to this is that it's kind of hard to figure out when you start working with this as a new developer on this code base, that you have to call InputRetriever.register blah 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 before running your application. Because it's not very explicit that this needs to be done, because it's just a static class. So somebody has to tell you that to be able to run this application or to be able to use the format converter, you need to go and set this other class up over here that you don't actually explicitly know that you need to change. And it's the same thing for the document persister like this. So static factory classes are actually quite useful for doing this, unless you use some help. So that's doing it manually. If you want to get away from doing it manually, you can use a service locator, for example. A service locator looks like this. If we look at the program file, you configure your service locator, which is basically telling a static class that here are the different types that I want to use for the different interfaces. Then I new up my format converter, but I don't pass in any parameters. I don't tell it what instances to use. I just new it up. And inside of that, I then go and say, service locator, in this case I'm using a Microsoft Practices one called service locator. I say service locator.current.getInstance, and then I say, can you give me an instance of iDocument serializer? And once again, it returns an iDocument serializer. Actual implementation doesn't matter. For some reason, people dislike the service locator pattern a whole lot. And there are reasons for it. One of them being that you don't know that to be able to use this class, you have to go once again and set something up over here, because internally that uses a class that you have to have configured at some other point in time and stuff like that. And number two, the service locator allows you to say, can I get an instance of, and then whatever type you want. And then we come back to the gnomes that you're giving people too much access and they can go and delete your database and stuff like that. So the service locator is generally disliked for some reason. I kind of like it. In WPF, it solves a bunch of really cool problems. And the last one, as I said, you get all this code, so you can have a look at that in more detail as well. But the IOC container, the IOC container sample, has a little bit of a different way. You create what is called a container. Your container is something its only responsibility is to know that interface X is mapped towards implementation Y. But it's smart enough to figure out inheritance chains. So if I tell my container, so down here I call up my container and create a container, which has iDocument serializer and IInputParser registered, I can then take my container and say, please, can you go ahead and pull out a format converter for me? It looks at the constructor for the format converter, which then requires, if we look at the format converter, it takes an iDocument serializer and an input parser as constructor parameters. So what the IOC container does when I request it to give me a format converter is that it looks at the constructor parameters and says, oh, so you need these two classes for me to instantiate you. Let me see if I can go and get hold of those. And if those classes then have other dependencies, it will go and figure out those dependencies. And if those dependencies have, and basically it just recursively figures out all of the dependencies that are needed for all of your classes to be set up. And finally, once it's configured all of your dependencies, it will create the class that you need and give it back to you. I like that. I use it in every single project. And you can also go and do something as wonky as put all of your IOC definitions in XAML, or in XML. So here's the app config. And in here, I'm basically saying to the container that whenever somebody wants an iDocument serializer, give them this implementation. Whenever they want to have an instance of input parser, give them an implementation of this. This means that I can actually run the same code, the same application, and then reconfigure my actual code at runtime by changing my XML configuration for the application. So I never have to recompile my application. I can give it new implementations without having to recompile my actual implementation, because all of my IOC configuration is in an external file. I like that. Some people don't. Some people are wrong. Benefits, well, once again, we create new implementations all the time due to open-close principle. We want to make sure that we don't lock us into a specific version because it's going to be a specific implementation because we can't switch it out. By using dependency inversion, we push our dependencies into our classes instead of making them us depend on other things that they have already decided. Does that make sense? Those are kind of all the principles, and I know I'm over time. I'm just going to give you 1 more minute, 2 more minutes. Some considerations to think about when you start with this. You are going to over-engineer and prematurely optimize your code. That's just going to happen until you know this well enough to be able to say, I don't need this at this point. You're always going to be fighting solid versus you ain't going to need it. And that comes with experience when you know to say, I don't need to do solid right here because. But it's better for you to say, I don't want to use solid here because, than I didn't use solid here because I don't know that it exists. Readability. Each class is going to be a lot easier to read. Your whole application is going to be harder to read because you're going to end up with a bunch of small classes, and it's not until runtime you know what's actually going to be used. Debatability. Leave knives and weapons before you go to lunch, because you will be spending your lunches with your friends talking about how to implement it, and it can get heated, and you're in a country where getting weapons is easy. I'm from Sweden, where getting weapons is really hard. And finally, does anybody know what 50 versus 230 is? The lines of code in my application. When I started out, it was 50 lines. When I ended it, it was 230 lines. Having that said, I have added some functionality. I can all of a sudden read from different places. I can persist to different places and a few little things. But you are going to end up with a bigger code base. But I'm telling you that a bigger code base doesn't necessarily mean a harder application to maintain. That's very important to keep in mind. That was it. Sorry for pulling over. I hope you got some information that you needed or wanted to hear. I'll be here for the rest of the week. So if you want to talk to me, just chase me down in the hallway and punch me so I stand still and then ask me. Thank you, everyone.